The Federal Aviation Administration maintains, operates, and oversees the largest and most complex aviation system in the world, controlling almost half of the world's air traffic with a safety record that is second to none. Looking ahead to the next century of aviation, the FAA is poised to meet the capacity demands of the future by developing new, collaborative strategies and performance targets that will accommodate more traffic, boost on-time performance, and enhance the ability to predict and minimize disruptions to the National Airspace System, or NAS. Collaborative Decision Making, or CDM, is a joint government-industry initiative aimed at improving air traffic management through increased information exchange among the various partners in the aviation community. One of the most high-profile and successful activities associated with the CDM community is the National Airspace System Operations Planning Teleconference, which takes place every 2 hours throughout each day. Hosted by the FAA Air Traffic Control System Command Center outside Washington, D.C., the Planning Teleconference brings together system stakeholders, including FAA traffic management, airport management, commercial aviation, business aviation, general aviation, and national defense. As a community, this planning team evaluates conditions that will affect the safe and efficient operation of the NAS and plan initiatives designed to mitigate the impact of those conditions. The planning teleconference is conducted by the planner located at the Air Traffic Control System Command Center. The planner hosts the teleconference, guides the group through the issues that need to be addressed, and facilitates group problem solving. The conference participants use a set of software-hardware tools that allow everyone to maintain a common situational awareness. These tools include Traffic Situation Display and Flight Schedule Monitor. Members of the planning team begin the actual planning for each teleconference well before the conference start time. The process begins by evaluating weather in both the en route and terminal environments. En route weather conditions such as thunderstorm activity and high-altitude turbulence are taken into consideration along with terminal area ceilings, visibility, snow and de-icing conditions, winds, and runway configurations. Planning team members also address route availability and terminal traffic demand. Considerations include areas impacted by thunderstorms that require traffic flow reroutes and periods of compact demand arriving at one of the nation's 35 busiest airports. Once the stage is completed, the planner hosts the teleconference and provides the opportunity for stakeholders to share their concerns. Stakeholders gain access to a phone bridge using an assigned passcode secured through the CDM membership. The planning teleconference can last anywhere from 15 to 45 minutes depending on the severity of conditions. The end result of the discussion is a collaborative approach to defining traffic management initiatives used to resolve various constraints in the NAS. Once the teleconference is complete, an advisory message is electronically transmitted that details system constraints and agreed-upon traffic management initiatives. The advisory is sent to FAA field facilities, airline operations centers, and other system stakeholders. The planner then briefs traffic managers at the Air Traffic Control System Command Center and monitors the ongoing operations to ensure that the plan is being carried out as agreed upon during the teleconference discussion. As the day progresses and needs change, the planner facilitates adjustments to the operational plan as needed. 2 hours later, the process begins all over again. The operations plan provides FAA customers with strategic information concerning traffic volume, weather issues, and airport constraints. Specifically, this information enables customers to reroute traffic around en route weather constraints. These reroutes are designed to add as little additional mileage to the destination as possible in order to save fuel. Meter traffic into a constrained airport. Effective metering eliminates the need for airborne holding, which prevents unnecessary fuel burn while waiting for an arrival slot into the destination airport. Manage the departure demand at a constrained airport. Coordinated use of gate holds and taxi times conserves fuel by reducing the amount of time a departure spends in the taxiway lineup. Coordinate optimum arrival routes into busy terminal areas. Advanced navigation arrival routes reduce the miles flown between the departure point and destination airport and improves the efficiency of arrival flows in the destination terminal area, thus reducing fuel use during the flight. FAA operations planning teleconferences are a prime example of the collaborative decision-making process. continued success in the information sharing processes among various partners in America's aviation community will enable the Federal Aviation Administration and its customers to meet and exceed the dynamic challenges and opportunities of 21st century aviation.